We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello friends, good afternoon. So we are meeting today after studying the Varignons Theorem. That is, it is basically meant for coplanar non-concurrent force system, and basically it is used to find out the position of a resultant, right? So what did we'll just brush up what we had studied in the previous lecture. That is, Varignons theorem states that when coplanar non-concurrent forces are acting on the system, then the moment of each force about a point is equal to the moment of the resultant about that same point. That is the statement of Varignons theorem, and Varignons theorem is basically used to find out the position. Till now we were able to find out the value of resultant force, that is magnitude. We could find out the direction of the resultant, that is at what angle the resultant is acting, but we were unable to find out the position. Okay, that means at what particular distance the resultant is acting. So to find out the position of the resultant, we have to use Varignons theorem. So today I am taking one numerical based on Varignons theorem, which will be helpful in finding out the position of the resultant. So you can see that this is particularly a diagram where we have got a square of, not square, we have got a rectangle of 30 mm by 40 mm. There are 4 forces acting at point A 60 kilonewton, at point B 120 kilonewton, at point C 50 kilonewton, and at point D 60 kilonewton. What does it say? We have to find the magnitude, direction and position of the resultant force. Okay. So what is our step number 1? So step number 1 is we have to find out the value of resultant, and to find the value of resultant we have to find out algebraic summation of all the horizontal forces. What does algebraic sum of horizontal forces means? That if the force is moving towards the right direction, we take it as positive. If force is moving towards left direction, we take it as negative. Now, if I see in this particular figure, what are the horizontal forces subjected to this? So one is at point B, 120 kilonewton, and it is moving towards right side. So plus 120. Then if I see at point D 60 kilonewton and it is moving towards left side, so negative. So sigma H, that is equal to 60 kilonewtons. Okay, this is the first thing we have found out, that is algebraic sum of horizontal forces. Now what is step number 2? So step 2 is to find out the algebraic sum of vertical forces. What is the sign convention? If the force is moving in the upward direction, positive. If force is moving in the downward direction, negative. So in the figure at point A, 60 is the vertical force which is in the upward direction. So plus 60, and another is vertical force at point C, that is positive as it is in the upper direction. So we get sigma V is equal to 110 kilonewtons. Okay. So we have found out the value of sigma H and sigma V. Both are positive. Okay. Then the third step is to find the magnitude of the resultant. How do we find the magnitude of the resultant? we have studied in our method of resolution to find out the magnitude of the resultant force, that is equal to R, and that is equal to under root of sigma h square plus sigma v square. Okay, so R, that is equal to sigma h, what we have calculated, 60 kilonewton. So we put it at 60 square, plus sigma v we have calculated as 110 kilonewton. So 110 square. So we get the value of R as 125.29 kilonewton. 125.29 kilonewtons. Okay, so we have found out the first thing, that is magnitude of the resultant force. Now what we have to find out? We have to find out the direction. What is the formula to find out the direction? So to find out the direction of the resultant force, the formula is, what is the formula? Tan alpha is equal to mod sigma v upon sigma h. Okay, so tan alpha, that is equal to, what is sigma v? 110. What is sigma h? 60. Okay, so we get tan alpha is equal to, both are positive, so it will come out, so tan alpha is equal to 111 upon 6. So alpha is equal to tan inverse 11 upon 6, which gives us the value as 61.38. Okay, so we have calculated the direction of the resultant force. Okay, now we have to find out the position. Okay, now to find out the position, we have to take the moment of the resultant force. Okay, we have to take the moment of resultant force about a point, and also we have to take the moment of all the forces about that same point. Okay, so first of all we will see that where does our resultant lie. Okay, so if I draw this as my x-axis, this is positive x, this is negative x, this is positive y, and this is negative y. Okay, now where is sigma h? So sigma h is plus 60. That means sigma h is in this direction. Where is sigma y? It is positive 110. So positive y, that is over here. Okay, that means my resultant is lying in first quadrant. Where does the resultant lie? The resultant lie in first quadrant. Okay, this is clear to all. Now we come to the position of the resultant. So first of all, we will take or draw a diagram in which we will show that, suppose this is our positive y-axis and this is our positive x-axis. Okay, because I've showed that our resultant is lying in which direction? First quadrant. Okay, so I am taking this as first quadrant and putting my rectangular block in first quadrant. Okay, this is point A, this is point B, this is point C, and this is point D. Okay. Now I don't know where is my resultant lying. So I'm assuming that suppose resultant is lying in this way. Okay. This is the resultant. So with respect to the point D, it is at a distance of x. Okay. Now what we will do? We will find the moment. What does the Varignons theorem say? Varignons theorem say that moment of all forces about point we are taking over here as D is equal to moment of resultant about same point. Okay, so what is the same point? B. Fine. So now we first take the moment of all forces about point D. That is, we are calculating moment at this point. Okay, so we can see that 60 line of action will coincide with D. This 60 will also coincide with D. So which are the two forces that are producing moment? One is 120 and another is 50. So I can show over here that this is 120 kilonewton and this is 50 kilonewton. I hope you have understood why we are not considering 60, both the 60, right? If you remember, I told you that when the line of action of the force, okay, coincides with the point, right, like this, so it will not produce moment because B is the point where we are taking moment. It will try to produce linear motion. Okay. Similarly, this 60, the line of action, if I extend, it is meeting at the point D where we are calculating moment. So again, it will try to produce a linear motion. Okay. But 120 is over here, right? So if I extend the line of action of 120, it is not coinciding with the point D. And we have got a perpendicular distance of how much? That is 40 mm. Okay, this distance is 40. Similarly, if I show over here 150 kilonewton, only 50 kilonewton, and if I extend the line of action, is it coinciding with the point D? No. So, it is also trying to produce the moment. Okay. So, now moment of all forces about point D. So 120 into perpendicular distance, as the force is horizontal, perpendicular distance will be vertical, that is 40. Okay, and how it will try to rotate? It will try to rotate in a clockwise direction. So that is considered as positive. Okay, similarly 50 kilonewton. So what is the distance up to point D? 30 mm. So into 30, and it is trying to rotate the body in anti-clockwise direction. Okay, so it will be minus, right? So if I find out the moment, what we get? It is equal to 3300 kilonewton mm. Actually, the units are all Newton. I have written by mistake kilonewton because if I am not considering kilonewton, then Newton mm. So this will be also Newton. Okay. So it is Newton into mm. This is our first equation, that is moment of all the forces about point D. Okay. Now our second is moment of resultant about point B. Okay. So I will consider it as R into perpendicular distance. I have taken it as X. What is the value of R I have obtained? 125.29x. Okay. So this is my equation number 2. So by Varignons theorem, 1 that is equal to 2. So 3300 is equal to 125.29x. So x will be equal to 3300 divided by 125.29. So that comes out to be 26.33 mm. Okay. So the position of the resultant is at a distance of 26.33 mm. Fine. So we have found out the last, that is position of the resultant force. Okay. Now suppose I will first again explain to you what we have to do. We have to find out the resultant. So to find out the magnitude of the resultant, we have to find out algebraic summation of sigma h. We have to find out algebraic summation of sigma b. And the formula for finding out the magnitude R is 125.29, 125.29, that is the magnitude. Okay. Then direction can be found out by using our formula. Tan alpha is equal to sigma b upon sigma h. So alpha is equal to 61.38, that is direction. And the last is to find out the position. We have to use the Varignons theorem. We have to take all the moments, forces, moment about a point, and we have to take the moment of the resultant force. Before that, we have to find out that our resultant is lying in which quadrant. So as horizontal component is positive, vertical component is positive, hence resultant will lie in the first quadrant. So I have shown the resultant in the first quadrant, and I am assuming it is lying at a distance of x with respect to point D, and thus by Varignons theorem we are getting the value of x as 26.33 mm. So I hope that any problem, if you follow these particular steps, you can find out the position of the resultant. Thank you.